Yo, Mr. Kaczynski here, working on IXL and Algebra 1, section EE, and in this video we're going to multiply radical expressions. We also have to remember what we learned about simplifying radical expressions. Pretty basic start here. Anytime you do a square root squared, you're going to get the number inside the square root. That's just 5. Square root of 5 times square root of 5 is square root of 25, which is just 5. Square root of 100 times square root of 100 is 100. Square root of pi times the square root of pi is pi. All right, here, again, pretty basic concept. If they're both square roots, you can take the numbers inside them and multiply them. So that's the square root of 6. Square root of 3 times the square root of 2 is the square root of 6. All right, same thing here. Square root of 2 times the square root of 10 is the square root of 20. However, unlike the last one, this one can actually be simplified because 20 has a perfect square factor, 4. So it's 4 times 5 is 20, and the square root of 4 is 2. So when we give our answer, we shouldn't leave it as the square root of 20. We should leave it as 2 times the square root of 5. All right, so we have to multiply, then simplify. Same thing here. All right, I'm going to do 3 square root of 45 times square root of 7 is 315. Actually, square root of 315. And then the square root of 315 can be broken up into perfect square factors. 315 is divisible by 9, and 9 is a perfect square. So 9 times 35, where 35 is not divisible by any perfect square, so 9 must be its biggest perfect square factor. All right, so we've got 3 times the square root of 9, which is 3, times the square root of 35, which can't be simplified. So our answer is 9 times the square root of 35. The 3 times the 3 can be simplified a little bit. 9 times the square root of 35. Same idea here, but we start introducing variables. All right, so I'm going to do 3 times 14, which is 42, which actually doesn't have any perfect square factors. But r cubed does have a perfect square factor, and that is r squared. So I'm going to write that kind of expanded out as r squared times r to the first. And then I'm going to go ahead and take the square root of r squared, which is r. And that'll leave us r times the square root of 42r. Again, 42 does not have any perfect square factors. Oh boy, looks like they're getting crazy. We'll do a couple of these here. First thing I'm going to do is multiply things together. So I'm going to write it as one big expression here. So 70 times 7 is 490. T cubed times t to the 5th is t to the 8th. U to the 3rd, there are no other u's. And then v to the 5th times v is v to the 6th. So let's write this now, expand it a little bit to account for perfect square factors. Like 490 is divisible by 49, which is a perfect square. T to the 8th is a perfect square. V cubed can be broken up into v squared times v, where v squared is a perfect square. I'm sorry. Let's make that's a u. I'm getting my u's and v's mixed up. So u squared times u would be u cubed, where u squared is a perfect square. And v to the 6th is a perfect square. So here we go. We got our 3. 49, the square root of that is 7. T to the 8th, the square root of that is t to the 4th. U squared, the square root of that is u. And let's get another color in here. V to the 6th, the square root of that is v cubed. And inside the square root sign, we still have 10u. Now outside we can simplify a little bit. 3 times 7 is 21. And then we still have the t to the fourth, the u, the v cubed, and the square root of 10u. That is, we multiplied the expressions together and then simplified by getting perfect square factors out of the radical. Let's do one more like that, and this one's even tougher because I got the 3 and the 7 outside. All right, 3 times 7 is 21. 15 times 70 is 1050. Oh boy, that's a big number. I know it's divisible by 25 though, which is a perfect square. B squared times b to the fourth is b to the sixth. And c squared times c to the fourth is c to the sixth, which those are perfect squares. So let's do this. 21 times the square root. Let's see, 1050 is divisible by 25, like I said. And it's 25 times 42, where 42 doesn't have any perfect square factors. So 25 must be the biggest perfect square factor of 1050. Then we got that b to the sixth, and we got the c to the sixth. So 21 times the square root of 25, which is 5, times the square root of b to the sixth, which is b cubed, times the square root of c to the sixth, which is c cubed, and inside the radical we still have that square root of 42 that cannot be simplified. On the outside, let's simplify now. 21 times 5 is 105, times b cubed, times c cubed, times the square root of 42, and that is our simplified radical. I know I'm a little crazy, but I actually like simplifying radicals. For some reason, this is fun for me. So if you need to, go back and watch some examples again. Multiplying radical expressions in section EE of IXL's Algebra 1 skills. Good luck. Let me know how it goes in the comments.